Alright, well, lesson 3 is about how we're going to deal with distance and displacement, about measuring them. So we're going to do some examples, and I'm going to do side views. Remember, there are two perspectives we can have. We can have a side view, or we could have an aerial view. So this is the aerial view. This would be us looking down on Einstein as he moves on a surface. This would be a side view where we're looking at him from the side, where this is up, that's down. This could be west, this could be east, or this could be north, this could be south. But the key thing, this would be up, down, and this would be some direction along the plane. So we're just going to use a side view for right now. So let's just imagine we have a line here. And let's just imagine this is the direction west, and this is the direction east. So west and east. Now let's imagine Einstein starts right here, okay? And he moves, starting from the beginning, so this is the beginning, he moves along in equal increments. These are roughly 10 centimeter increments, I believe. No, 5 centimeter increments. So here we go. Let's imagine here's the beginning. Einstein moves from here to here to here, and let's say he finishes right here. Okay, now the total distance he's traveled is 5, 10, 15, 20 centimeters. So the distance he's traveled is 20 centimeters, 0.2 meters. The displacement is from beginning to finish is 0.20 meters, but it has a direction. It's to the west. Okay, so that's a simple journey. Now, one of the things students get confused of is they'll see, oh look, this is 0.2 and this is 0.2. So that's exactly the same thing. These things are the same thing. What's he making a big deal about? Well, I'm going to show you how you're completely wrong if you believe that. And don't feel bad about it, because we're going to be wrong about a lot of things as we go along. A lot of your beliefs are going to be not how the world actually is. So let's just see how a different scenario where Einstein actually changes direction, and these will be two different values. So I'm going to give another scenario. So here's a new scenario. Let's just suppose Einstein begins here. And remember, each one of these segments is 5 centimeters, so 0.05 meters. So let's say Einstein starts here, and then he went here, 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 here. Okay, so we'll put a little dotted line to say he got to this point. And let's imagine he came back here, 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 and finishes. Okay, so let's total up. Let's see what the total distance he traveled. He went 5, 10, 15, 20. So if I was to write these down, there's 0.10 meters from 0. This is 0.20 meters, right? Because this is 5 centimeters, 10 centimeters, 15, 20 centimeters. Then he turned around, went here, 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 and here. This is actually minus 0.10. The minus, we're going to discover, means the opposite direction of the 0 position. So let's total it up. The total distance traveled is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The total distance traveled was 50 centimeters. Now, let's look at the displacement. He started here and finished here. The shortest line segment joining that goes from here to here. How many centimeters is that? 5, 10. He went 10 centimeters, 0.10 meters, and which direction is that? East. This is his distance that he traveled. This is the displacement he had through space. This is a scalar, and this is a vector. Two different types of measurements. Now we're going to use them to become more apparent later on. So, in a recap, Einstein started here, jumped to here, 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 turned around, boom, 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 boom. That's the difference between distance and displacement. So, we'll do one more example really quickly, and then we're going to take a look at, in the next lesson, something called velocity and something called speed. So, here's a really simple situation. Again, we'll have is little 5 centimeter increments. Side view. Let's say that this is the 0, this is 0.10, this is 0.20, so these are 5, 10, 15, 20, 25 centimeters, and this is minus 0.10. So let's say this time this is south and this is north. Let's imagine instead Einstein started here. And let's have him move the following way. He begins here and he moves like this. 1, 2, 3, 4, 5, 6, 7, 8. He's back where he started. So let's see the total distance he traveled. He went 1, 2, 3, 4, 5, 6, 7, 8. He went 5, 10, 15, 20, 25, 30, 35, 40. His total distance he traveled was 40 centimeters. But look at his displacement. He begins and finishes at the same point. How long is that? Zero meters. His displacement is 0. Now with that, this is a special case of vectors. When a vector has a 0 value, we really can't say it has a direction, because which way is it pointing? So here you can see again that this scalar quantity and these vector quantities are different things. Now the whole thing that's missing this time is we haven't talked about is there's a clock running while Einstein is moving back and forth. In the next lesson, we're going to take his movement in space and time and talk about his velocity and his speed.